Okay, so we'll start with single responsibility, which basically is, to me, this is kind of related to functions should only do one thing. This is the class level expression of that, which basically says a class should have exactly one reason to change. And we talk about an axis of change of a class as being a responsibility. And the idea is that changes to one axis shouldn't affect the others. So a rule of thumb is if you can describe in sort of 25 words or less what is the one thing that this class does. If you remember when we talked about CRC cards as an aid to doing design of your different classes and identifying what the models in your app were going to be, what responsibilities they would have, that's actually pretty closely tied to this. You should be able to sort of, on an index card, write down what is the thing that this class is responsible for, what is the type of entity, and what are the operations that that entity has to know how to do on its own, and what are the things that it has to collaborate with other classes in order to do. And a tip-off is models that have many sets of behaviors. And this is actually a big pitfall in applications like the ones we're building, because the natural starting point for model view controller apps in software as a service is the logic goes in the model. And it is a very slippery slope for a single model to start accumulating all sorts of cruft. For example, almost every app that is being built by the projects in this course has some model that in some way represents who the user is, right? Because most of us are building apps that are user-facing. So following our simple example, we had the movie reviewing app. So a moviegoer is a user, but it's also an authentication principle, right? How do you determine who's logged in? Well, the idea of logging in isn't really identical to the idea of a user. In fact, there's a lot of sites that let you log in with a username and password, or they let you log in with your Facebook or GitHub credentials. So it's immediately pretty evident that the concept of logging in is not intimately tied to the concept of a user, but it's close enough that they tend to end up in the same model, right? Because if you're asking yourself, where should the logic go, that seems like a natural starting point. And then if you add the idea that, well, users in my app can have friends, so they can have sort of a little social network within the app, now there's the concept of the user having a friendship. But again, the friendship is a functionality that is defined by its own set of behaviors that maybe is different from what the user-specific behaviors are. So probably this is the principle that apps in this class are most likely, if you're not careful, to find yourself violating. Because there's a temptation to sort of start putting all of your logic into a small number of models, even if the logic is not sort of intimately tied to what that model is about. And you can measure this. So lack of cohesion of methods, which is, again, one of the many great metrics that Code Climate computes for you. The intuition here is basically if you have a certain set of instance variables in your class, and you have a certain set of methods in your class, then if the class really and truly has only one responsibility, it should be the case that most of the variables are touched by most of the methods, right? So if the class really only does one thing, and the different methods are sort of facets of handling that one responsibility, it stands to reason that most of the state associated with a class instance is going to be needed by most of those methods. If, in contrast, what you find is that when you sort of draw that graph of which methods in the class touch which variables, and you end up with sort of little sparsely connected components, that's a sign that there's actually probably more than one thing happening in the class, that you can actually separate out maybe into a couple of different classes, and you might be violating single responsibility. And by the way, a lot of these design principles, again, there isn't sort of a magic value of LCOM above which you're a violation and below which you're in compliance, right? Like all of these metrics, these are intended to sort of guide you in the right direction. There was a debate for a little while in the Rails community about active record. And the debate was active record is bad because as a class, meaning the class from which your models inherit, it actually violates SRP. Why is that? Because whatever your active record model might be, users, movies, whatever, look at all the things that it knows how to do. Models can load, save, and delete themselves in the database. There's all this machinery about associations. There's the machinery about validations. And that's all in addition to whatever your model is supposed to be about. I actually don't really buy this argument because in some sense, these are behaviors that get mixed into the class, right? The idea of associations is not specific to any one active record model. It defines really something that's more like an interface and a set of behaviors that can be added to anything that behaves like an active record model. So when I think of a model in this case, I think of the thing that your code does and not the additional mixed-in mechanisms that active record provides to make it easier to represent that as a database stored model. And in fact, if you look at the way active record is authored, if you look at the source code, all of that stuff is actually included as modules. It's not really part of the base class. So I actually don't buy the argument that active record violates SRP. But what would? Here's a simple example of a sort of a way that even in a simple class, this can creep up on you. And I have a hypothetical customer class that, there we go. Didn't realize that there was that much animation. If a hypothetical customer class, customers often have an address. It is worth asking the question whether behaviors related to the address actually belong in the customer class or not. Even if it's the case that there is no other type of model that you have that has the concept of having an address, you could argue that things like validating a zip code or canonicalizing a mailing address, those are not things that are about a customer. Those are behaviors that can be isolated in some other class. So one way that you can address something like this, do you see what I did there? Come on, wake up. Give me some love. One way that you can address something like that, thank you. I'm here all week. One way that you can avoid this problem is instead of putting all the behavior in the customer class where it would go by default, suppose we pull out a separate class and we define some methods on that class. In fact, we can actually tell the address class that whenever somebody tries to call any of these sort of address-specific functions, we can actually define those methods back in the customer class and delegate them back. So what does that mean? It means that the abstraction of what happens to an address can be encapsulated in its own class, but that class doesn't have to always implement the functionality. And this is an example of composition and delegation, which is, if there's sort of an underlying meta pattern in the solid principles, it's that inheritance usually isn't the best way to solve the problem. If what you want to do is compartmentalize and reuse behaviors, it's better to compose, meaning that now, because the address logic is in its own class, but it's delegating these accessors, you can still have the benefit of storing all this stuff in the customer's table. So notice the difference, right? If you look at the customer's table schema, in the table, customers will have a zip, a street, and all of the other stuff. But the logic that is associated with how those things are manipulated and computations that really have to do only with them can get pulled out into a separate class. From the point of view of changing the code, that behavior can now be separated out. And there's actually a facility in Rails that helps you do this. Right? Oh, and by the way, we have drawn some class diagrams before, but now we're saying here's our base class, our customer. It inherits from active record, as we've always done before. But now, when a customer has an address, when that customer is, what we want to have happen is when the customer is loaded into memory from the database, we actually want to have one attribute of the customer be an instance of this other class that has its own methods and that can manipulate all of, it can do computations related to the address, but all the while, the actual values, the underlying fields of the address will still end up being in the customer's table. Right? So how do we do that? There's actually a really nice mechanism called Composedov, which I'm not going to show the code for the example, but if you have cases like this, it's easy enough to look up. But the idea of Composedov is you can say the customer has a field, address in this case, and address is its own class. So the accessors for things that are stored about the address, that's still part of the customer's table, but Rails will arrange that when the field gets loaded from the database, this will get set up automatically. So if I say that my customer is composed of an address, and I tell Rails what the attributes of the address are, then anytime I load a customer, it will automatically arrange for it to be the case that the address attribute of that customer gets initialized to a new instance of the address class. The instance of the address class has the correct attribute values that came from the customer's table. And conversely, if I make changes to these in the instance of the address class, then when the customer is saved back, all of the right things will happen. Right? So again, active record provides a way to get between the representation we want to have in memory, which is address is just one component of a customer, and it's an instance of a different class, even though in the database, the information that is related to an address will actually be stored along with the customer. So separating out a little bit the representation as we store it from the representation as we manipulate in memory. Okay? So this is a relatively simple example, but the point of the example is to show basically that even if the reason that you use models is because you have to store stuff. And when you have to pull out a class in order to avoid having one class doing too many things, you don't necessarily always have to create a separate table for that class. The idea of creating the class but delegating the storage of its attributes back to the containing class is fairly natural to do, and so Rails gives you a mechanism for it. Summary of the single responsibility principle. What did we say? It says that a class should have exactly one responsibility. That means it has only one reason to change. Going back to our simple example, the thing to understand is if we decide to change something about the representation of the address, or we decide to change, how do you compute whether an address is valid or the zip code's valid, those changes now do not touch the customer class at all. If we add attributes, like maybe we will even add new fields to the address, and that will result in a change to the database schema if we're still storing that stuff along with the customer model. But the customer class itself no longer has to change. Tests related to the customer class will not have to change. So isolating the things that change from those that stay the same. How do you know if you might have this problem? If you have a high LCOM score, or quite simply, if you have a long class. If that class file .rb includes a couple of hundred lines, it's very hard to argue that it's really only doing one thing unless that one thing is really complicated. And in particular, if you can, sometimes you can sort of visually identify groups of methods within a class that seem to rely on each other, but don't really have much of a connection to the rest of the class. So that's a good example of when you might be in trouble. What can you do? You can extract a class. That's by far the most common thing to do. There are other methods that include pulling reusable behaviors out into modules and things like that. That's actually how the active record library kind of got started, is that if you find yourself building over and over again adapters that allow you to store stuff in a database, you'd say, well, can we pull that set of behaviors out and mix the behaviors into any class we want without any knowledge of what the attributes are? So that's the idea.